In this video here, we're going to take a look at the mean value of a function. We're now going to learn how we can find the mean value of a function. And you can think of the mean value of a function as the average of a function over a given interval. So for some function f of x, the mean value of f of x over this given interval from a to b is given by the following result here. So we use f bar to represent the mean value of a function. So f bar here then is equal to 1 all over b minus a times by the integral of f of x with respect to x from a to b. And just notice here then that the mean value f bar will simply be a real number. So it's not a function, it is just a real number. So the result for the mean value of a function is also not given in the formula book, so just make sure then that you do familiarize yourself with this result. So moving on to the next page here then, what I want to quickly demonstrate to you is a geometrical interpretation for the mean value of a function. Now we can easily derive the result for the mean value of a function by considering the area of a rectangle and the area under a curve. So if we use this diagram here then to help demonstrate and explain this concept, what I've got here then is this curve with equation y equals f of x. I've got this purple horizontal line here with equation y equals f bar, and I'll come back to that in a moment. We also have this green shaded region here, and that also goes underneath this rectangle here, or is part of the rectangle here. So this area is the area under the curve with equation y equals f of x. And as you can also see here then, we do have this rectangle here, which has this kind of orange tint or shade to it. And we're between then a and b here. So to start with then, we do need to be aware that for the mean value of a function, the area of the rectangle will be equal to the area under the curve with equation y equals f of x. Okay. So this should be pretty straightforward, right? Just basic A-level maths integration. So the area under this curve, y equals f of x between a and b, is given as the integral of f of x with respect to x from a to b. So as I've already mentioned, right, that should be pretty straightforward. As a concept, it's just basic A-level maths integration. And the same is true for the area of the rectangle. In fact, that should be pretty much elementary at this point. So just base times height, right? So my base here is just going to be b minus a. Now for the height here, my height then is going to be f bar. Okay, because y is equal to f bar here. So base times height gives us b minus a times by the height, which is f bar. So in that case then, we just obtain f bar times by b minus a here. And in that case then, the mean value of a function is given as follows. So because we've just already mentioned then that the area under the curve is equal to the area of the rectangle, what we do here then is we equate these two results. So in that case then, the mean value of a function is given as follows. So we obtain f bar times b minus a is equal to the integral of f of x with respect to x from a to b. And in that case then, if we just want f bar here, the mean value of a function, all we need to do here then is just divide through by b minus a. And in that case then, f bar is equal to 1 all over b minus a times the integral of f of x with respect to x from a to b. So there we have it. That gives us a geometrical interpretation for the mean value of a function. So before we work through a couple of practice questions here for the mean value of a function, there is just a few properties that we need to be aware of then for the mean value of a function. So to finish with here then, let's just have a quick look at the properties of the mean value of a function. So if the function f of x has mean value f bar over this given interval from a to b and k is a real constant, then f of x plus k has mean value of f bar plus k, again over the same interval from a to b. So for the second property here then, k f of x has mean value of k f bar, again over the same interval from a to b. And then finally here, the very last property, we say that minus f of x has mean value of minus f bar, again over the same interval from a to b. So that gives us the three properties here then for the mean value of a function, and that concludes this introduction here then to the mean value of a function. So to finish with then, let's just work through a couple of practice questions together. So let's just get started here then with question 1. So for question 1 here, we're given f of x which is equal to 1 all over x plus 2 And for the first part of this question and part A, we want to show that the mean value of f of x on this interval here from 0 to 2 is a half ln 2. So for part A then, don't forget here that for the mean value of a function, so this is just f bar here, this is equal to, so we get 1 all over b minus a times by the integral then from a to b of f of x with respect to x here. Okay. So in that case then, what do we get here for f bar? So we obtain 1 all over, so we do 2 minus 0. We then times this by the integral from 0 to 2 of f of x, which is 1 all over x plus 2. So 1 all over x plus 2. And don't forget here then that we're integrating with respect to x. So dx there. Okay. So let's just simplify this here and evaluate this integral here. So 1 all over 2 minus 0, that just gives us a half, right? So we get a half there. Now for this integral here, nice and straightforward, right? So the derivative of my denominator would be the numerator. So in that case, then what we get here is a half times by ln of my denominator here. So ln of x plus 2. Okay. And don't forget here then that we do also need to evaluate this with these limits here from 0 to 2. Like so. So we start with the upper limit here, and then we subtract the lower limit. So in that case, then we get a half times by, so we get ln of 2 plus 2, so that's ln 4. We then subtract the lower limit here, so ln of 0 plus 2, we get minus ln 2 there. Okay. And what we can do now to finish with here is write this difference of logarithms as a single logarithm. So in that case, then what we get here is a half ln 2, because writing this as a single logarithm, we get ln of 4 over 2, and 4 over 2 just gives us 2 there. So we get a half ln 2 as required. So as required there, and that gives us the solution to part A. So now for part B then. So for part B then, it says, hence find the exact mean value of the following functions over the same interval from 0 to 2. So to get us started here then, we have 4 of x. So for 4 f of x here, all we need to do is multiply the mean value of f of x from part A by 4, right? So we've got this constant here on the outside, so k f of x. We just times the mean value of f of x here from part A by k, which in this case is just 4, right? So therefore, the mean value of 4f of x over the interval 0 to 2 is, so we take this here then, just times it by 4, right? So in that case then, 4 times a half is 2, so we get 2 ln 2 there. Okay? So that gives us the solution to part 1 of B, and then for the second part here, the very last part of this question. So for part 2 then, we've got f of x plus 1 here. So in that case then, all we need to do is take the mean value from part A and just simply add 1. Okay, so for f of x plus 1, in that case then, the mean value, so we have f of x plus 1 again over the same interval from 0 to 2 is given as, so like we already mentioned, then we just simply add 1 to this mean value here. We get a half ln 2 plus 1. Okay. And there we have it. So that gives the solution then to the very last part of part B, and that just gives us the solution to question 1. So let's just have a go now at the very last question here. So we have question 2 then, and we're given f of x is equal to x cos 2x. The question then asks us to find the exact mean value of f of x over this interval here from 0 to pi over 2. So to get us started here then, let's just begin by stating the result for the mean value of a function. So f bar here then, don't forget we just use f bar to represent the mean value of a function, is equal to 1 all over b minus a. We then times this by the integral here from a to b of f of x with respect to x. Okay. So in that case then, what do we get here for f bar? So therefore f bar is equal to, so we get 1 all over, so a here is 0, b is pi over 2, so we get pi over 2 minus 0. We then times this by the integral here from 0 to pi over 2 of f of x, which is x cos 2x. So x cos 2x there. And don't forget here then that we integrate with respect to x. Okay. So what we need to do here now is use integration by parts to evaluate this integral here, right? We have a product of functions. So let's just evaluate this integral here then using integration by parts. So we have the integral here of x cos 2x with respect to x. So what we need to do here is choose u and also choose v prime. We've got u and v prime here. So in this case here, u will either be x or cos 2x. So it makes sense here to choose u equals x because once we differentiate that, we obtain 1, right? We just obtain a constant. So in that case then, u equals x here, and u prime is simply 1, okay? So v prime would be the remaining function here of cos 2x. So cos 2x there. What we also need now is v here. So v would be the integral of this here with respect to x, which just gives us a half sine 2x. We get a half sine 2x there. Okay. So now let's just evaluate this integral here then using integration by parts and everything that we've got here. So we obtain uv, so that's x times a half sine 2x. We get half x. We get half x sine 2x. Minus the integral then. So minus the integral here then of u prime times by v. So we just get a half sine 2x there. So a half sine 2x with respect to x, like so. So let's just evaluate this integral here then. So a half sine 2x with respect to x. Well, if we integrate sine x with respect to x, that just gives us minus cos x here. So this integral now would give us a negative trigonometric function. So because we've got a minus of a minus here, the result would become positive, right? So we get a half x sine 2x. We can't do anything with that. So a half x sine 2x. Can't do anything with that as we already mentioned. Plus, so if we integrate this here then, what would we get? So what I'd actually get here is minus 1 over 4 cos 2x. Because we've got minus here, we get minus 1 over 4 cos 2x. We get plus 1 over 4. So 1 over 4 cos 2x there. Okay. So going back to our result here then for the mean value of a function. So 1 all over pi over 2 minus 0, so that's just 1 all over pi over 2. And 1 all over pi over 2 would just give us 2 over pi. We get 2 over pi there. We then times this by this result here, because don't forget we haven't evaluated this at these limits here. We get half x sine 2x plus 1 over 4 cos 2x. So cos 2x there, like so. And we evaluate this from 0 to pi over 2. Okay. So don't forget then we start with the upper limit here and subtract the lower limit. So f bar then is equal to 2 over pi. We'll just keep that on the outside for now. So what do we get inside here? So starting with the upper limit, and let me do this in a separate bracket here just so you can see the difference in between the upper limit and the lower limit here. So we get a half times by pi over 2, so that just gives me pi there. We then have sine of 2x. So if x is pi over 2, that's sine of pi. So we get pi, sine pi, like so. We then get 1 over 4 cos pi there. So plus 1 over 4 cos pi, like so. So that's my upper limit there. We'll close that bracket. We now subtract the lower limit here. Okay. We get 1 over 2 times by 0. So this first term here would just be 0, right? Because 1 over 2 times 0 is just 0. It doesn't matter what sign is here. That would just be 0. We then have 1 over 4 cos 0. We've got minus 0. That was this term here. Plus 1 over 4 cos 0. Okay, we'll close that bracket there. That's the lower limit here. And let's close the full bracket. So now let's just simplify this here as we keep going. So f bar is equal to 2 over pi. 2 over pi. What do we have here? So sine pi is just 0. So I get 1 over 4 cos pi here. 1 over 4 cos pi. Obviously, the 0 has no effect here. So minus then 1 over 4 cos 0. So minus 1 over 4 cos 0. Okay, like so. Well, cos of pi is minus 1. So what we get here is 2 over pi times pi. So 1 over 4 times minus 1 gives us minus 1 over 4. Cos of 0 is 1. So minus 1 over 4 times by 1 just gives us minus 1 over 4. So minus 1 over 4 minus another 1 over 4 just gives us minus 2 over 4, which is just the same as minus a half. So what I've got here then is 2 over pi times by minus 1 over 2. Okay, the 2's will just cancel here, like so. And what we get left with here then is f bar is equal to minus 1 over pi there, like so. Okay, and this here then gives us the exact mean value of f of x over this interval here from 0 to pi over 2. So there we have it. That gives us the solution to the very last question here, question 2. And that brings us to the end then of this video here on the mean value of a function.